All right, so welcome back. Last week was a little bit challenging. We had a lot of different content to learn, and this week is a little less challenging, but we get to do some actual math. In this assignment, we'll be doing our paired sample t-test. Of course, we're back to using SPSS. SPSS. Our question that we are looking to respond to is, on a bowling team, does a 15-minute coaching session have a significant effect on individual bowling scores? We have a data set with three variables. And as you can see right here, we have students, game one, game two. And you can see this is how they bowled in game one before coaching, and this is how they bowled in game two. Our game, I just mentioned our game one indicates no 15-minute coaching, and our game two indicates that. The null hypothesis is that there is no statistically significant difference between the coaching models and bowling scores. Our alternative hypothesis is that there is a statistically significant difference between 15-minute coaching and scores. We're going to look at the scores between the two games, but we need to see is their normal distribution. In SPSS, we will go to transform. We're going to compute our variable. In the target variable, we're going to type the word difference. And then in our numeric, we're going to do game two, move it over, minus game one. And then we're going to click OK. Now, if you notice, we have a new variable called difference, and you can see there is some negative impacts as well as positive impacts. As we were told in our feedback, we need to demonstrate knowledge, and we will go to up to analyze to look further to see if the scores are distributed normally. Once I analyze, click descriptive statistics and go to explore. And it's funny because it took till this assignment for me to understand, oh, explore, we're exploring more data. And then we're going to move difference to our dependent list. And we'll click plots. Like usual, we want to take off the stem, we want to put on the histogram, and we want to put on the normality plots with tests. And we'll click OK. And then let me just make sure I have this correct. And we're going to click OK. And we should see our lovely summary here. We have descriptives. We have test of normality. We have our histogram. And I actually like when I have to put the bell curve on because you can see it. And you can kind of look and see how this is going up and down. And then the line plots as well. All right. So I'm going to go right back up to here. And you can actually see that we're looking at the difference in normality distributed. So we will go to the Shapiro-Wilks test and look at significance. You can see that we have, that's all the way down here, significance of 0.337, which is greater than 0.05, indicating that the normality is distributed evenly. I wanted to come back up here and point out kind of the mean here. You can see the mean, average mean was 4.950, and then the minimum and maximum. But that being said, we need to now go do the sample p-test, the sample paired samples t-test. Oh my goodness, I wish I could speak today, because we want to look and see our comparison. We'll go back to our favorite analyze button all the way over here. And then we're going to go to the compare means and proportions. Oh, clearly I'm clickety-clicketing. Compare means and proportions. And we want to go to the paired samples t-test. All right, once we are at the paired sample t-test, we're going to move game one to our paired box, paired variable, and we're going to move game two to our paired variable. And then we need to go to options to make sure everything is okay. And we're looking for that 95%. Options, we're there. All right, continue. And then we need to make sure we have our estimate effect sizes so that we know what we're looking at when we talk about the sample effect size. And we'll go to OK. And again, now you see our t-test. We have the paired sample statistics. We have the paired sample correlations. We have the paired samples test and the sample side effects. We're going to look at the paired sample statistics first. And on that, you can see the average mean from game one was 90, and the mean went up for game two to 94, but not significantly enough. And the standard deviation was 13.5 for game one and 14.318 for game two. And you have your standard mean of error. Again, your sample size was 20 in, and then we have our paired t-test that we're going to go to right here. And you can see that when you're comparing the two, you have a negative 4.95 and our two-sided p-value of 0.108. And we already know that's greater than 0.05. So this is kind of telling us we're failing to reject the null hypothesis. I do want to go back to our t-value right here is a negative 1.685 as well. And this is our degrees of freedom. But again, back to this, we know that's over that zero point zero 0.05. So it's indicating that our exploration of the 15-minute coaching sessions did not produce statistically significant improvement in bowling scores. Now, one other thing we actually learned this particular week was that we have to, I always mess this up, and I know this was a question in our class. We have to find the percentage of change. And so we're going to do that. I need to open up my calculator. Let me go to my calculator. Don't look at my computer. Calculator. And in order to do that, we do 94.95 minus 90, which was that means, our means and means, and we get equals 4.95. Now we're going to take 4.95, divide that by 90, which gives us a 0.055, and this is where it gets that percentage title. We have to multiply it by 100. And now we have 5.5% because we did that multiplication. So what that tells us, student bowling scores improved by 5.5% after the 15-minute coaching session, showing no statistically significant difference. And that is a paired t-test.